All right, hello students. Good morning to all. So today, very good. I'm found now sound. All right. So I hope voice is clear and video also check whether you are getting good clarity or not. If everything is good, inform to me so that we are going to start our class. All right, Garima, good morning. Eshika, Soni, good morning. Radhika, good morning. And Jayant, good morning. All right, here and last class, Eshika was came for present and left. Jayant. So this class kindly be till the end. I will ask in the middle your names. You should be present till the end of the class. Okay. All right. Meanwhile, remaining all come and join. So whoever not present, inform to me that. Vishnu is said good morning, sir. He said good morning, sir. Kanishka said good morning, sir. Kindly come and join and said yes. So he said everything is clear. Then let's start our today 27 and it is your 11th class. Chapter 16 probability. In this we are going to discuss exercise number 16.3. Okay, so once again we'll recall definitions, then again we'll start our class. Okay, let's it and automatically you are going to get back to the live. Okay, Hishita today present or not? If you are present, just say to me that is present, sir. And Himanshi Soni, your present means inform to me I am present, sir. So Garima previously came, whether she is still here? Yes, Garima is here and remaining all also here. Very good. So let's, before going to discuss our class, so let us close our eyes. We'll pray first, then we'll start our class. Let's close our eyes. God, kindly provide your knowledge and wisdom. Mathematics problems and Basant. So inform to your friends, let them come and join in that. Okay, let's move on to the exercise number 16.3. So in that we have to discuss today from problem number 11 onwards we have to discuss. So before going to that, what we need to understand, what is a probability? Probability is nothing but measure of uncertain phenomena. So measure of uncertain phenomena is nothing but a probability. And probability consisting, there are many. Last time we discussed about what is classical theory of probability, what is axiomatic probability. So let's move on. I think today present only 6 students are present. I'm finding here 6 students, 2 are outsiders, only 6 are our students. Okay, now 5 students only present. Let me see that. Okay, so if you are facing any internet issue, kindly refresh it and then listen. Okay, let's move on to our problem number 11. In a lottery, a person chooses 6 different natural numbers at random from 1 to 20. So there is 1 to 20 numbers, they were written in a piece of paper. Okay, and from that they are going to select 6 numbers randomly. Okay, now if these 6 numbers match with the 6 numbers already fixed by the lottery committee, so whichever they are collected that 6 numbers, so that 6 numbers are fixed, so that numbers are matched with the fixed numbers of that lottery pricing committee, then he wins the prize. Otherwise they are not wins the prize. That means what they are going to do here, it is, listen this, how the lottery process will be. There should be one box. In that box the papers will be kept. Here it is 1 to 20 papers are there. That 1 to 20 papers are they kept, and then they are mixed up. After mixing, you are going to collect 6 numbers. So that six numbers are, if it is matched with the that lottery numbers already fixed by the committee, then you are going to win the lottery. Otherwise, you are not going to win the lottery. So that we need to understand how it is. So for that purpose, let's understand. And what is here? They said here, hint, it is given as order of the numbers is not important. Here they say order of the number is not important. So order however it is also, but we need to find what is the probability of winning the prize in the game. What is the probability of winning the prize in the game? Very simple question. How to solve? First we need to find how many number of ways collect that, to collect that papers. So six numbers I want, six numbers choosing. You need to find how many number of ways are there. So let me write here number of ways to choose six numbers out of 1 to 20 numbers. That means 20 numbers is equal to total 20 numbers. In that 6 I need to select, so that 20 C6 is nothing but selecting number of ways to choose six numbers. Okay, so now 20 C6 is nothing but what we are going to get. So you know that NCR is nothing but what is your formula? N factorial upon n minus r factorial into r factorial. Use that 20 factorial after that into 6 factorial. So 20 factorial, 20 into 19 into 18 into 17 into 16 into 15 into 14 upon, so here 14 is there, 14 factorial into, here 6 factorial means 6 into 5 into 4 into 3 into 2, correct? So now 14 factorial get cancel. Now 3 ones, see 5 threes are 15 and here 15 get cancel. So any other possibilities are there? Let's check here. So 6 fours are, okay, it is not possible. Let's see here. Now normal cancellation will do 4 ones, 4 fours are 16. So then 2 ones, 2 twos. Then again 2 ones are 2 threes are 6. So then 3 table 16 into 6 into 17. Multiply and tell to me what is your answer for that. How many number of ways to find out six numbers out of 20? So 20 C6 is nothing but this many factorial upon 14 factorial into 6 factorial. When you simplify, what you are going to get answer, fastly write your answer. Okay. So Garima already written 38760 is right answer. So you are checking outside backside answer or what? So if you are not checking backside answer, Garima, so then it is well and good. I'll appreciate you for that. If you are checking backside answer and saying answer, so it is not appreciable. Okay? Yes, it is 38760. 38760. Yes, you are correct. 38760. That many means 38,760 ways. 38,760 ways. Okay, Garima is laughing. Okay, all right. So number of ways to choose that we done. And anyhow, in lottery, only one person is going to win, not every person, right? Giant, if you are there, just keep the thumb symbol so that I get to know that you are here. Hmm? So how many lottery, if lottery is there, how many persons can win? Only one single person. So that means what are the favorable outcomes? Only one. So now we can write here it is, right here it is total, that is outcome to win lottery is equal to only one, because that committee is fixed only one person, not every person, right? So committee is always fixes only one person, not 100%, not 200%. So lottery is only for one person. That person is a luckiest person, right? So then here we are finding the chances of winning a lottery ticket. So this is favorable outcome to win lottery is nothing but one. Why it is? Committee is already fixed only one number. So therefore probability of winning lottery is equal to favorable outcomes upon total number of outcomes. So answer for you, favorable is 1, total is 38760. So then your answer finished. I hope you all understood this. Okay, Himanshi now came. Good morning, sir. Yes, only for good morning. Please don't come only for good morning. Everyone just stay until the end. Okay. Garima is written now n of e upon n of s is equal to 1 upon 38760. Okay, she is given this E, favorable outcomes as E and then written. That's okay. So, however, answer is 1 upon 38,760. Okay. So that is about your problem number 11. And today maximum we are going to complete this chapter. Then our syllabus is going to be finished. Then later what we are going to do is every day we are going to discuss very important questions in chapter wise. Okay, then we are going to discuss fill in the blanks, means 1 mark questions, those all. So that time it is very important sessions for tomorrow onwards for your examination point of view. Okay, so everyone need to be present. All right, let's move on to the next one now. So that is problem number 12. Simple question, problem number 12 onwards. All are simple questions. Just you need to concentrate on the board. Problem number 12, they said that check whether the following probabilities, that is probability of event A and probability of event B, are consistently defined, Remember here always one thing, probability of events, whichever that is P of A or P of B, should be less than or equal to, P of A intersection B. It should be, sorry, it is less than or equal to the P of A union B. This remember. Another one you should know, P of A and P of A intersection B, probability of A intersection B. This you should remember. So always P of A and P of B should be less than or equal to the A intersection A union B and should be greater than or equal to the probability of A intersection B. Let's check now the first point. So who is writing something? Okay. Not that formula, don't go for that. Okay, just remember this. P of A should be less than or equal to P of A union B. P of B is less than or equal to P of A union B, means probability of event A, probability of event B should be less than or equal to the A union B. And the Probability of A, probability of B events are greater than or equal to the P of A intersection B. Now let's go for the first one. P of A is equal to given as 0.5. Now P of B is given as 0.7. P of A intersection B is equal to 0.6. From this you are understood that P of A intersection B is greater than P of A. Therefore, we will write here it is not consistently defined. It is not defined. That's it. So just it satisfies this condition or not satisfying, not consistently not defined. If it is satisfied, you can say consistently defined. Let's check next one. P of A is equal to 0.5. P of B is equal to 0.4. P of A union B is equal to zero point 0.8. Now check carefully. P of A union B is greater than this or not. So here what I was written, P of A is greater. See, this is my mistake. So you all change this one. P of A intersection B is greater than or equal to P of A, and this also P of it is intersection. Correctly written. P of A greater than P of B is greater than. See here now. P of A union. P of A should be less than or equal to P of A union B. P of B also less than or equal to probability of A union B. Here you observe that P of A union B here is 0.8, which is less than P of A is less than A union B, P of B also less than A union B. So here you write P of A is less than P of A union B, and then P of B also less than P of A union B. So then you write therefore it is consistently defined. Okay, once again listen carefully the conditions. So first condition is P of A should be less than or equal to P of A intersection B, and P of B should be less than or equal to the P of A union B. And then next one, P of A should be greater than or equal to the P of A intersection B. P of B is greater than or equal to the P of A intersection B. So if these conditions are satisfied, then we can say it is consistently defined, otherwise not consistently defined. When you observe first one, not consistently defined. Any one, if you get greater than P of A also, it is not consistently defined. And A union B is given, P of A union B, so should be greater than P of A and P of B. It is E also less than P of A union B. Now zero point 0.8 here and this is 0.5. 0.5 is less than 0.8? Yes. Zero point 0.4 is less than 0.8? Yes. So therefore it is consistently defined. Okay. I think somebody writing something. Okay. Very good. So Garima writing still that all. Okay, that's good. So that is about your problem number 12. Now let's move on to the problem number 13. Okay. Garima was done good job yesterday. She was observed who are coming lately, who are until the end, who is there, who is not there. Everything was written as a data manner. Very good. Good job you done, Garima. Today also complete in that way. Submit to me. Later I will take some action towards that. Alright, let's move on to the next one. Problem number 13. And my special appreciations to her. She was doing good job. And similarly, Hishita also doing good job nowadays. She is more active. Vishnu also more active. That's well and good. And heat also. Anyhow, now P of 13th one, P of A is given, P of B is given, P of A intersection B is given, P of A union B is given. So means they were given a table, you have to complete it. So before going to that, you should remember this: N of A union B is equal to N of A plus N of B minus N of A intersection B. This you learned in the sets. Same thing only here, but here N place you are going to use probability of A union B is equal to probability B. That we are going to use. Let's check the first one, what given. 1 upon 3 given, this is 1 upon 5, this is 1 upon 15, and this should be dash. So now, what is probability of A union B? Probability of A union B is equal to, I said just remove N, write probability. Probability of A plus probability of B minus probability of A intersection B. So 1 upon 3 plus 1 upon 5 minus 1 upon 15. Now LCM take as 15. Now 3 table when 15 will come times, so that 1 into 5, and 5 table when 15 comes 3 times, so 1 into 3, and 15 table 1 time, so 1 into 1. So now 5 plus 3 minus 1 upon 15. 5 plus 3, 8. 8 minus 1, 7. So 7 upon 15 is your P of A union B. Okay, I hope you all understood this. So already who is written only formula? Okay, 7 upon 15 written by Garima. You are doing good job. Why online class means Garima is going to be more and more active while compared to the offline class. And Hishita much fastly answers, right? Okay, now Hishita started. Okay, it is 0.5, 0.6. Okay, next one you are solving. That's good, Hishita. Okay, second one given here B is question mark and P of A intersection B and is equal to 0.25 P of A union B. So is equal to 0.6 is given. Now you know that P of A union B is equal to P of A plus P of B minus P of A intersection B. Just substitute the values. 0.35 is equal to P of A. Okay, this is P of A union B, 0.6. So right here 0.6, 0.35 plus P of B minus intersection B is equal to 0.10. 35 minus 25 is nothing but 10 plus probability of B. Probability of B is equal to 0.6 minus 0.1. So probability of B is equal to 0.5. So 0.5 is your answer. And third one do as a homework. Third one do as a homework. Okay. So who is laughing there? Hishita is laughing again. Garima laughing. Okay, well and good. So there is so much appreciations was done for the students. That's good. So third, do as a homework. And let's move on to the next question. So let's check whenever clarity is missed, immediately inform to me. If you are not able to inform, then it is big problem for me. Okay, I could not able to find out anything. Okay, so Vishnu also writing answers. Good. Vishnu, Garima, Heath, and Hishita. These are more active nowadays. Huh? Good. So now next one, 14th problem. Given P of B is equal to 1 upon 5, A and B are mutual section in that. That means this is A set, this is B set. Then like this, no joint is there. That means no common elements are there. Then we can say that mutually exclusive. Okay, so that means there is no intersection, or simply we'll say P of A intersection B is equal to 0. So now what I need to find? P of A or B. So A or is nothing but union. P of A union B is equal to P of A plus P of B. So here we won't get intersection B. We will get only P of A and P of B. So now this is equal to P of A is nothing but 3 upon 5. P of B is nothing but 1 upon 5. Totally 4 upon 5. That is about 14th question. I hope you all understood this 14th one. Very good. Yourself you all appreciating, right? That's good. So Hishita written, Garima written. Only these two students firstly writing answers. So your typing speed also. So next we'll go for next problem. That is 15th one. If E and F are even such that P of E is equal to 1 upon 4, P of F is equal to 1 upon 2, P of E and F means E intersection F is nothing but 1 upon 8, then first one I need to find P of E union F. Simple questions are asking for you all. So then P of A plus P of B, sorry, here E and F, right? So P of E plus P of F minus P of E intersection F. Then 1 upon 4 plus 1 upon 2 minus 1 upon 8. Take LCM as 8. 4 table when 8 will come 2 times plus 2 table 4 times, then minus 8 table 1 time is 5 upon 8. Right. So after that 5 upon 8. Then second one it is given as P of not E. Question again. Opposite this you can write and then solve the problem. It becomes very easy. So this how we will write 1 minus E. And opposite is R. Not opposite is not remove, then F. So indirectly they were saying for you what is probability of not E and not F is nothing but 1 minus P of E or F. That means 1 minus P of E or is nothing but union F. 1 minus P of E union F already you found, I think, that is 5 upon 8. Just write here 5 upon 8 and subtract, you get answer as 3 upon 8. How? 8 ones are 8, 8 minus 5 3, 3 upon 8. Finished your answer. I hope you all understood this. Very good. Radhika giving chocolates for them, and then Hishita is writing, okay, all the answers. That's good. Hmm. Okay, Garima enjoying with that. Okay, all right. That's about your 15th one. Let's move on to the 16th question now. All are easiest questions. Actually, no need my help if you know these all formulas. If you don't know, then only it is required my help. But what can I do? I have to explain for you all then. 16th one. Let me write here 16th problem. Events E and F are such that P of not E or not F is equal to 0.25. State whether E and F are mutually exclusive or not. So what is meaning of this mutually inclusive or mutually exclusive we need to prove. So let's check whether it is possible to prove or not. Probability of not E or not F is equal to, they said, 0.25. Okay, let's check now. P of oppositely, how you'll write not E or not F, 1 minus probability of not E means we'll write E, or means and F, not F is nothing but F. Now check 1 minus P of E and F. So that means P of E intersection F. So now this is nothing but how much given? 0.25. Write that 0.25 is equal to 1 minus probability of E intersection F. Minus comes to here plus, and this plus go to that side minus. So now probability of E intersection F is equal to 1 minus 0.25. That is nothing but 0.85. Now tell to me whether it is possible or not. What is mutually exclusive? Mutually exclusive meaning is that so that P of A intersection B should be 0. P of A intersection B should be 0. But here it is what you are getting 0.85, which is not equal to pi or not equal to 0. So that is the reason it is not mutually exclusive. Therefore, it is not mutually exclusive. Clear? So if 0 comes, we can say that it is mutually exclusive. 0 not came, that is the reason it is not mutually exclusive. Now let's move on to the 17th one. So A and B are events such that P of A is equal to 0.42, P of B is equal to 0.48, P of A and B, that is nothing but P of A and means intersection B is equal to 0.16. I need to find what? First one, P of not A. That is nothing but 1 minus P of A. So 1 minus 0.42. You get 0.58. Finished your first and second one now. P of not B. You need to find P of not B. Not B means again 1 minus P of B. That is 1 minus P of B is nothing but 0.48. So you get 0.52. Next, third one, what I need to find. So third one I need to find it is P of A or B. P of A or B. That is P of A union B. So P of A union B is nothing but what is you have formula P of A plus P of B plus minus P of A intersection B. So we have all you have P of A. So you have P of A, P of B, and P of A intersection B. Just substitute, get the answer. So it is 0.42, another one 0.48. So 10, 8, 9, 0.90 minus 0. Next one 0.16, 0 minus 0.16, 4, 8 minus 1, 7, 0.74. So answer is 0.74. Finished your answer. Understood? Any doubt you have? Okay, written 0.74 by Heath. That's good. And Vishnu also written, that's well and good. Okay, very good. You all doing good job. Okay, let's move on to the next. So, till now we finished up to problem number 17. So, 18, 19 I'll complete. And then at least 2 problems I will try to give as a homework for you all. Okay? So 18th already written by Shita. Let's check. Okay. Let's move to the next one, that is 18th question. In 11th of school, 40% of students study mathematics. How many percentage? 40%. Always remember, percentage is nothing but a probability was given. Okay, percentage, if you are written in the form of decimal, that is nothing but the probability of mathematics. So I'll write here, probability of mathematics is given as 0.4. 40% is because of that, and 30% is biology. So that probability of B is nothing but it is given as 30%, so that 0.3. 10% of the class study both mathematics and biology. So probability of mass intersection biology, so is equal to zero point 0.1. Then, if a student is selected random from the class, find the probability that he will be studying mathematics or biology. So means M union B, we need to find out. So probability of M union B is equal to P of M plus P of B minus P of M intersection B. So that is M is 0.4, next one 0.3, next one 0.1. So 0.4 plus 0.3 minus 0.1, 0.2, you get answer as 0.6. Okay, that means 60 percentage of students study maths or bio, maths or bio, or you can write probability of maths or bio studying students is equal to zero point 0.6. Completed your answer of 18. Let's discuss 19, then we'll close this session. Last problem for today, and remaining two I'm going to give as a homework. 2021 you need to do as a homework. Easy questions. So just you need to concentrate on that question and then complete by your own. Okay. Now 19th one. Similar question again. In an entrance test that is graded on the basis of examinations, two examinations, the probability of a randomly chosen student passing the first examination is zero point 0.8. So first examination passing is zero point 0.8. That means first exam, let's say A. So probability of A is equal to zero point 0.8. Probability of passing second exam is 0.7. Let's say second exam is B. So here I'll write first exam is equal to A, second exam is equal to B. Let I'll keep. Okay, is equal to 0.7. Next, probability of passing second examination is 0.7. The probability of passing at least one of them is 0.95. At least one of them is 0.95. What is the probability of passing both? So at least they said means that is maybe that is one of them is nothing but P of A union B is nothing but 0.95 is given. Now I need to find probability of P of A intersection B. Both examinations passing is I need to find out. So let's check what is formula. You already know probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Now A union B 0.95, probability of A zero point 0.8 plus 0.7 minus probability of A intersection B. Now 0.95 is equal to, so it is, what do you get, 8 plus 7, 15. So 1.5 minus probability of A intersection B. So now minus here comes to your plus, go to that side minus. So probability of A intersection B is equal to 1.50 minus 0.95. So what you are going to get? 0.55. 0.55 at last. So that is about your problem number 19. Very good. So whoever given that is 0.55, for them give claps everyone. And remaining two, 20 and 21 problems are homework for you. Thus we finished our probability chapter. Okay. Tomorrow onwards, very important sessions are going to start, because we are going to discuss only important questions and then 1 mark questions later. So first important questions chapter wise, then we are going to discuss 1 mark questions, then we will finish it off. Okay, you all understood? Okay, all right, may God bless you all. So our time is up.